shales. There's one there, little shale break. And then here you could do a couple of different things. You got the nice big sand at well number 2. You could do it as a lens, or some people even put this shale break as come up like that, because they think we're trying to trick them. Actually, this shale break here is a big shale class that's sitting, it's about 6 feet long, that's sitting right in the middle of that sandstone. And so we purposely ran our log over it so we'd get a shale kick so that we could trick people. Now, that wasn't my idea. I think, see, weren't you on the
Yeah, but you didn't resist it much.
No. At any rate, most people would do something like this. Maybe not exactly, but I looked around at yours and they were kind of like that. It's perfectly all right. In reality now, nothing correlates between the 3 wells. Here's actually an oversimplification of, it's more complex than this, yeah. But we just kind of simplified. The sand in the middle is not, you know, there's boundaries on both sides of it and so on. So as I asked you before, well, what are you going to do? You're going to walk into the boss when you have those 3 wells and say, sorry boss, this field trip they taught me not to correlate. You won't last long in the company. Yeah. So my answer to this is that you do one of 2 things, or preferably 2 of 2 things. One is to do a couple of different correlations, have a range of possibilities, and then assign a risk factor or an uncertainty factor to your correlations.
Let me interrupt a second.
Go ahead.
How many people here went through Deep Blue 2 with me? What is that called that he's talking about? We called it multiple working hypotheses, where you have several different possibilities, several different models that you're working at the same time, and you assign a probability to each model and risk weight them. That's exactly what Roger's talking about. Multiple working hypotheses is a very crucial feature that you need to do in geology.
Now I realize that you want to have one answer, but I would be on the safe side and say, well, here's a range of answers with a high degree of uncertainty. And I would say this to you, that if you know from seismic or whatever that this is the type of environment your reservoir was deposited in, that you ought to go for the range of uncertainties rather than one interpretation. Okay, because this is the way they are in the subsurface. Okay, so that, yes sir. How much?
How much risk factor?
Well, that's a judgment call that an individual would make. I don't know quite how to answer that, but I could do a couple of different correlations here, and I could say, well, knowing the depositional environment, I think this one has a higher probability of being correct than that one.
But I don't know this. I have not seen this query. I've just seen this.
But you have seen the quarry now.
Just if I have not seen the query, if I try to correlate, I don't know anything. How will I?
Very easily.
That's what it's.
You read.
Analog.
If you know you're in this type of environment, you go to analogs. You go to
guys,
analogs.
you ought to have known that looking at that picture before they gave you those logs. There was undulations, there were all sorts of scours, loads, and everything else. There wasn't anything with uniformity unless it's maybe those diastemic unconformities, what you're going to call them. I don't believe Alan Thompson or this gentleman here or Doug Jordan or this gentleman here or John or anybody, if they saw that photograph you got on front, the only 2 questions you got, is that fluvial or is that deep water canyon? And that's the only places I know where you could put them, and we don't get the cross bedding and other things. And so
well, they both have the same problems of continuity, though.
See this. Roger, all he has is these gamma ray logs.
yeah, but he had that picture to start with.
But when we're digging subsurface, all we have is the logs. You got to go back and research it.
Yeah, well, if you have seismic,
you got to get back somewhere.
If you have seismic, that's your best clue to the environment of deposition.
Right.
Okay? And that's what I said. If you know, remember what I said, if you know the environment of deposition, you can make some predictions that it's going to be this complex. I could give you 100 examples of these types of reservoirs where they show logs and, you know, production problems, discontinuities, all that. Me and another guy wrote a book 2 years ago that we published where we had a chapter on these types of bodies, a chapter on another type, and so on, and we put in a lot of reservoir examples. What are the issues with each type of reservoir? This type of reservoir, the issue is continuity, okay, because everything lenses at different sizes.
I have the book.
Well, it's okay. You should have read it.
I read it.
Now you go back, you'll see these pictures in the book. And that's what I mean by, or what Bob just said about research.
Here,
You know, you got to know
hit
something
the
about the
well
regional
number
geology.
3.
And Ramona says, I don't care.
Well
I
number
just want to
3.
know how fast, how much. But part of getting to that answer is knowing
number
the
2.
regional
Stop.
geology and how the rocks were deposited, and most importantly, what is the environment of deposition, because that's going to tell you the continuity, so you can go back to how much, how fast. And particularly the big question in this type of reservoir is how fast. Okay, you got a high net sand, there might be full of hydrocarbons, but it's going to be how fast can I get it out with all these discontinuities. So, but you've got to know something about the geology to be able to, when you do, you can make some educated guess using analogs.